Hello. Okay, today our lesson is going to be on similarity. By the end of today's lesson, and after you take notes, you should be able to define and determine similarity. So, similarity is having the same shape, but it's a different size. We saw this when we did our transformations unit. We learned about 4 types of transformations, if you can remember, and one of them the figures were the same shape, but a different size. Can you remember which one that was? If you said dilations, you are correct, or dilations. Increasing or decreasing a shape makes what's called a similar figure. So we're going to expand a little bit on our knowledge of dilations today and look at it more closely in what makes the figures similar. How are they similar? So our first question is, how do I determine if two shapes are similar using transformations? I have 2 triangles pictured on a coordinate plane, triangle EDF and HGI. In order to determine if they're similar, we're going to use something that we learned in 7th grade. We're going to use ratios to compare the side lengths from one triangle to the other. So you can tell that EDF is smaller than HGI. But what we have to see is if, from our last lesson, if corresponding sides have the same ratio. So remember, corresponding sides are sides that are in the same place on a different figure. Side ED would correspond with side HG. And in the picture, we're told EG is 4 units. Actually, we can count it. I don't know if you're told. I think there aren't numbers in yours. So you count 1, 2, 3, 4. It's 4 units, ED. HG, if you count 1, 2, 3, 4, 5, 6, 7, 8, is 8 units. To write the ratio, we would put the small triangle, 4, ED, in the numerator, the big triangle, 8, HG, in the denominator. And if we can simplify the ratio, we'll simplify it. 4 over 8 is 1/2. Now what we have to see is if all the other corresponding sides in the triangles have the same ratio. If they have the same ratio, then they are similar. So DF is that base of the triangle on the small one. That's 3 units from D to F. GI is the base on the big one. It's 6 units from G to I. 3 over 6 also simplifies to 1/2. You have to make sure all the side lengths match up. Now we can't count on the slanted side or the hypotenuse because these are right triangles, but we can use something from another previous unit, the Pythagorean theorem. If you notice, 3 and 4 are the start of a triple. It's a 3, 4, 5. And 6 and 8, you can divide each of those by 2 to get down to 3 and 4, so that's also a triple. So the slanted side on EDF would be 5, and the slanted side on HI would then be 5 times 2, which is 10. 5 over 10 is 1/2. So these are similar because ratios are the same. It is a dilation, and it is a dilation with a K, or scale factor, of 2. The second question in your notes, how do I determine if two shapes are similar using scale factor? We have what would be considered a level 2 word problem here. A photo is enlarged by a scale factor of 2. If the original photo was 2 inches by 3 inches, what are the dimensions of the print? Is the enlarged photo similar to the original? Okay, so again, always go to writing a ratio. The original is a 2-inch by 3-inch photo. We're going to enlarge it by a scale factor of 2, so that means to multiply both parts of our ratio by 2. It becomes a 4-inch by 6-inch. So yes, it is similar. It's another dilation, and we knew the scale factor was 2. Our third question for today is, how do you determine if two figures are similar? This is a level 1 question, you're just given the two shapes. These are triangles. They wouldn't be considered right triangles because we don't have 90-degree angles. You can see the measurement in there. It's not a 90-degree angle, it's an 80-degree angle. Hello. So it would be an acute triangle. Again, to determine if they're similar, you have to match up corresponding sides. Now, in the small one, MLN, that one's upright. The big one, SQR, is turned upside down. So you have to imagine rotating it so that R then becomes the top, so that you have the 80-degree angles in the same place. And you can actually draw that in if you want to. Draw it in big below there and rewrite the letters, match up the sides. Sometimes that is helpful. And your drawing doesn't have to be perfect. And especially because of the way you're taking notes right now, just do the best you can. So that puts R on the top, Q and S with our 80-degree angle here. And RQ is 8 and QS is 6. So it kind of helps to maybe turn around the shape, do that reflection, rotation, whatever it may be, translation. And then write your ratios. So ML corresponds to RQ, 4/8, simplifies to 1/2. LN corresponds to QS, 3/6, simplifies to 1/2. And we have two corresponding angles that are the same measurement. So because of those three things, we can say they are similar. They have the same ratios. I have a little graphic organizer just for you to keep straight the difference between similar and congruent. In similar figures, the side measures are different. They can be bigger or smaller as long as they increase by the same K or scale factor. And the transformations you use for similar figures are a dilation. But congruent figures, which we worked with in our transformations unit, the side measures are equal or congruent, angle measures are equal or congruent, and the transformations used are rotation, reflection, and translation. So there are some differences between if you have congruent figures or similar figures. Just make sure you make note of that, and that's something we'll come back to after break. There's some practice for you to try and to submit through Google Classroom. Good luck.